Okay, this is EUREKA Online, where we teach you tutorials on your subject courses. This is the best online tutorial that will point you through, or that will put you through all what you are expected to know in physics, in chemistry, in mathematics, in biology, in statistics, in computer science, and every other subject or courses that you are doing in your school. So today we are going to continue with types of function. We are going to continue with type of function, and below are the type of function. We have one-on-one function, one-on-one function. We have one-on-one function. Two, we have an onto function. Onto function. Three, we have a into function. Into function. We have a constant function. Constant function. We have constant function. We also have identity function. Identity function. So we'll be taking that one after the other, and I'll be representing them using arrow diagram, so that you can get a true picture of this type of function. The first I will handle is one-on-one function, or one-to-one function. One-to-one function. One-to-one function. One-to-one function is a type of function in which each domain is able to pair with each range. Each domain is able to pair with each range. For example, in sports, maybe football, you see that one opponent is able to pair with another opponent, or one attacker is able to attack another opponent. A football pitch, we call it marking. One is able to mark the other. So when one is able to mark the other, we say this is a one-to-one function. Okay, so we can use an arrow diagram. Okay, let me write it down. A one-to-one function is a function in which one domain is able to pair with one range. We call it one-to-one. For example, look at this arrow diagram. I have a 1, 2, 3. I have a 4, 5, 6. Look at 1 is able to pair with 4, 2 is able to pair with 5, 3 is able to pair with 6. You can also have it in this way. It's not necessarily one opposite the domain. I told you that this is domain in D, and this is codomain CD. But because it's able to pair, you see its range. So that all is a codomain. So we can have in this way where I have a 1, 2, 3, 4, 5, 6. Okay, so look at 1 can pair with 6, then 2 pair with 4, and 3 pair with 5. So we can have it this way. It's just that this is able to pair with the other. So we have another kind that's opposite to this. Another one that's opposite to this, so that you can get the two picture of 1 in 1. So that you can get the two picture of 1 to 1. Look at this. Look at this as an arrow diagram, so that you can understand the arrow 1 to 1. Look at this arrow diagram. We have a 1, 2, 3. We have a 4, 5, 6, 7. Okay, look at this now. So you just see that 1 is able to produce 4. Okay, 2 produces 5. So let me do it this way. Let me do this. 2 produces 5. And look at the 3 produces 5. So you can see that this is not 1 to 1. 2 is able to produce 5. 3 is able to produce 5. So we just see that this is not 1 to 1. You can see the difference between them. The other one, each variable, each domain produces each range. One range is attached to this mark this. So in this kind of situation, you see that 2 people is marking one opponent. Yes, in football, there are 2 people marking one opponent, and that is the case whereby this team, maybe they've collected a red card. Okay, so you see that the number is lesser. So you can see. So we can easily say that this is not 1-to-1 function. Okay, another type of function is onto. It's onto function. Onto function. I left it here so that you can memorize more the type of function. So that is we have an onto function. Onto function is a type of function. Onto function. Onto function. This is a type of function. Don't forget that function is also called marking. Okay, function is also called marking. Okay, so this is a type of function in which all the values at the codomain site is not able to form a range. So there are some value that is unable to pair with the domain. So in that kind of situation, we say we have an onto function. Look at it. We have this. Look at this arrow diagram. Arrow diagram. 1, 2, 3, 4, 5, 6, 7. So let's assume that 1 pair with this, 2 pair with this, 3 pair with this. So you see that 6 ought to pair, but since it's unable to pair, we say that 6 is not a range. So the number of codomain is higher than the number of range. The number of all the number in the codomain side is unable to pair with the domain. All the number in the codomain side is unable. So we can also take it that is a type of function. Is a type of function. In which all number, all the number are the codomain side is unable to pair with value at the domain side. Okay? Domain side. So it's a type of function in which all the number at the codomain is unable to pair value at the domain side. So you can see that we have 1, 2, 3 at the domain. So I think that this is domain, and this is codomain. Okay, so you will see it's unable to pair. Because of that, we say this is onto function. We say this is onto function. So this is onto function. Okay, we can have unto. Unto is a type of function. Unto is the type of function in which unto function. This is a type of function. In which two value at the codomain, at the domain is able to produce single image. All the function is the type of function in which a single two values at the domain side is able to produce the same image or range. No, another name for range is image. So look at this arrow diagram. Look at this arrow diagram. We have a 1, 2, 3, 4. We have a 5, 6, 7, 8. We have let me put it like this. So we have this to this, this to this, this to this, this to this. So this is what we call unto. This is what we call unto. Okay? So apart from unto. So apart from unto, we also have constant function. This is the type of function in which all the values at the domain side, all the elements at the domain side is only able to give one image, only one image. Identity constant function is a type of function in which all the elements or values are the domain side is able to produce or give one image or range. So look at this. Look at this arrow diagram. We have a 1, 2, 3, 4. We have only 6. So this to this, this to this, this to this. Okay. So all is able to produce 6. So we can say that this is an arrow. This is a constant function. Identity function is the next. Identity function is the next. So when we say identity function, we are talking of a domain that is able to produce itself. Yes, a domain that is able to produce itself alike. A domain, identity function, is a type of function in which a domain is able to produce itself alike. Okay, look at an arrow diagram of this nature where we have maybe A, B, C, D. Okay, so we have A is able to produce A, B is able to produce B, C is able to produce C, G is able to produce. So you can see they produce themselves alike. Okay, if I have 1 here, number 1 here, 2, number 2 here, and 5, number 5 here, so something like that. So this is what we call identity function. So another important thing I will take you through this morning is kind of function. So don't forget that we're still taking a function as we talk. Kind of function. We have even function. We have odd function. We have neither. Yes, we have neither even nor odd function. Neither even nor odd function. So let me quickly explain each and every one so that we can solve some questions. So we have an even function. Even function is a kind of function in which the inputs, after substituting negative variable to the variable that is given in the function, it gives back the original function. Yes, it gives back the original function. So we can say that even function is f of minus s equals to f of s. Okay? So substitute minus s for the function that is given, and it gives us back the original function. This is even function. Okay? So we can also have an odd function. Odd function is if you substitute a negative variable to replace the variable in the function. The negative variable to replace the variable in the function. It gives us the opposite of the original function given. For example, this is can illustrate using f of f of minus s equals to minus f into minus into f of s. Yes. So if you substitute it, we just see that the original function is gotten. The original function is gotten, but we are going to get negative multiplying by. We can also have one that we call neither even nor odd. Neither even nor odd. So we see that neither. So it's a kind of function in which if we don't get back the original function that is given. Also, we don't get the opposite of the original function that is given. So we get another kind of function. Okay? So you can just say that f of minus s is not equal to f of s. Okay? And that means it has two conditions. So two, we have f of minus s is not equal to minus f of s. You open and close that. Okay? So that is just what we putting you through here. So what we'll now do now is to start solving questions related to even and odd function. The question relating to even and odd function. Relating to even and odd. So let us take some questions. So examples. State whether okay, examples. So just examples, okay. So state whether the function given below is even, odd, or neither. So let's take Roman figure 1. So we can say that we are having, let's just say we have a function f of s equals to s squared minus s raised to power 4. Okay? So please watch and see what we're going to do. The first thing to do is to solution. The first thing to do is to see that you substitute, pick f minus x. So substitute minus s for x in the function equation given above. So let's see, we have the f of s equals to s squared minus l squared 4. So that's the original question. So the next thing is to now substitute it. So we have a f of minus s. So we have used minus s to replace s. So it's going to also come across every other variable here. So we have a minus s all squared. Yes. So minus s to replace f. So minus, open another bracket, minus s raised to power 4. Okay. So now it's like we are having two things there. According to law of indices, each of them will have their power. The power distributed. So f of minus s equals to minus 1, so we'll just factorize that minus 1. We put the square. Yes, we put the square. Yes. And that's what we'll do. So that will give us minus 1 raised to power 4 into s raised to power 4. Okay. So, and anytime we have a power that is even, and what is raising it is negative. What is raising it is negative, then that will become positive. And if it's odd, the power is odd, the negative become you still maintain the negative sign. So because it's even, this negative one become plus 1. Become plus 1. So if you know even number are number that you can divide without remainder. Odd number and number that when you divide them, they are going to be remainder. So example of even numbers are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, like that. So example of odd number are 1, 3, 5, 7, we have 9, we have 11, so you can see that means f of minus s equals to, so this one become 1 plus 1, so 1 times s square, we have our s square, then minus, this one also become plus 1 times s square, we have our s square. So you see that when we substitute f of minus 1, we get back the original question. So this is the original question, and this is the answer gotten. So this is the function. The function is an even function. So that is one thing about even about this function. So let's take other examples and see if we can get what we can get there. So let's take other example. Look at example 2. So let's just take it with even or odd. Let me delete this one. Let me delete this. So we can also state whether this is also odd or even. F of x equals to s raised to power 3 minus s raised to power 3 minus s raised to power 4. Let's check this. So, okay, solution. F of minus s equals to minus into minus s raised to 3. Okay, you see it. Then we have minus s raised to 4. So we have f of minus s equals to minus 1 raised to 3, okay, into s raised to 3. Oh, you see, we are going to factorize a minus 1 from this x. Yes, we are going to factorize minus 1. So minus, don't forget that the original minus is there, which we don't need to tap out. It's only the alphabet, the variable that we want to change. So any constant here will not change. So we have minus 1 raised to 4. Okay, is the what? S raised to 4. So this gives us f of minus 1 equals to, this one is minus 1. So minus 1 times minus here, we have plus. That means I have, times this we have 1, I have my s minus, what of this one? I have what's name? Plus, because this is equal. So times this minus become minus, and rest is equal. Okay. So if you check where you see that we did not get back the original portion that was given. Secondly, we did not get the opposite. The opposite means that we're going to factorize out minus 1. We factorize out minus 1. And then we're not going to have minus s cubed and minus x squared 4. So that it can be odd. But this is not odd. You can say it's neither odd nor even. Okay? Neither. So let's take another example. I hope you are making a note of this kind of function. Yes, please do, so that you can enjoy the topic more. So look at, let's take another question. Yeah, let's take another question. We have f of s equals to, see, the same question is what we are trying to use. The same number 1. Okay, f of s equals to s cubed minus s cubed plus s cubed plus s raised to the power 5. S cubed plus s raised to the power 5. Okay, so let us see solution.